Okay, so I'm going to talk about kind of a different topic. It kind of includes physical geography, climatology, engineering. So it's kind of a collaborative research question and venture. So basically what I'm going to be doing is modeling the effects of winter storms on power infrastructure systems. And this is important because we're able to model the potential outages from certain weather events. That will help power companies prepare their resources. It will help emergency managers. It will help a bunch of entities prepare for the event and possibly lower outages time periods. Okay, so what is known? So we obviously know that winter weather events in general, specifically tropical cyclones, winter weather such as ice storms, large snowstorms, they cause an extensive damage to the the power infrastructure system, which leads to prolonged outages. I'm sure some of you have experienced very long power outages. I know growing up in Louisiana, we had constant hurricanes, so that was a big deal in Louisiana. So, like I said, so currently we have a large array of literature on tropical cyclone-related outages, and that is a great thing because that kind of sets the path for what I'm going to be doing. So, the important thing about modeling tropical cyclones is that those are predicted with 3 to 4, 5 days in advance. So those are not easy, but they're relatively easier than winter storms because winter storms are a bit trickier. The path and the amount of precipitation changes hourly with each model run that the forecasters use. So as you can see, the winter storm outage modeling lacks big current research time period. So again, I'm just going to stress again, there's a large knowledge gap with winter storms. And so if you're wondering, well, why is there this gap? Well, it's because predicting the spatial and temporal scale of winter storms is extremely difficult. I'm sure if any of you have lived in the northern United States where it snows or anywhere else in the world where you get a lot of winter weather, the chances of the forecast being right 2 or 3 days out, it's very low for winter storms because of where the snow and ice line is, where the rain transitions from snow, sleet, ice, all that. So that's the reason there's a gap, and it's going to be a big venture to do this, but I'm excited about getting it going. And so what are the contributions? So we want to narrow this gap. So obviously this is very early in the research, so we want to take the gap that there is right now, which they have a few papers on ice accretion on power lines, and we want to take this research and actually develop a spatially generalized model that can be used anywhere in the northern United States, or hopefully in the future anywhere in the world that will be able to predict power outages from winter storms. And so if you're wondering what some of the variables are that might matter when you want to model this, land cover use and land cover type. So if you have developed area versus a wetland, or well, not a wetland for winter storms, but if you have developed urban, that matters because it tells you how many people are in that area. So that will also help you be able to predict the amount of outages. And then another issue with this type of research is that getting outage data is not very easy because power companies are typically very reluctant to share this information, either because they don't have it or it would take a lot of time for them to get it together, and they want to actually benefit from this. So another thing we do is we tell them that they can actually use the model, so they're then more likely to give us the data. And so in order to do this, you need data from past storms because you need to be able to train the model. So what we would do then is we would take the data that we obtained from past storms, the past big events in the northern United States, and actually train the model with that data. And so why does this matter? So that might seem like a trivial thing, but like I said, if we're able to model this, we can substantially lower the outage times if we can better prepare crews and equipment such as poles, transformers. And so this actually might be able to lower the outage time period. And it also might be able to give information to the power companies that they can use to better their system. And so one other thing I want to point out is this research is very collaborative, so it's perfectly fit within geography. It includes climatology, engineering, emergency management, and other geographers, including human geographers, because outages affect human lives as well. So there could be some relation with outages and human health, so that would be interesting.